Good morning, students. Yesterday's lecture, we have learned about different factors like Z transformation, p value, and about the different laws of probability, laws of addition, and laws of multiplication. In today's lecture, we are going to learn about variance and standard deviation, and at the end, we are going to learn about the standard error. Okay, basically, all these things are associated with the mean of any data. As we all know, that standard deviation, basically deviation of or dispersal of values around the mean, are called as standard deviation. Okay, so if any data, if you take any data, okay, if the mean is same, if you'll take different datas and if the mean is same, but it might be possible that the lower values and higher values may be different. Okay, in the first year we have learned about it, that sometimes the mean comes same, but the data is varying in different ways. Okay, so in that conditions you have to find out the deviation of that data from the basic mean or the arithmetic mean. Okay, so measurement of variation or dispersion. Measurement of variation measures the degree to which the observations vary about the central tendency value. Now, what is the measure of central tendency? That is the mean, median, and mode, which provide information on the data values at the center of the data set, which measures of the dispersion, that is the uh, quartiles, percentiles, ranges, provides information on the spread of the data around the center. Ranges you must have aware about, or the percentile you calculate, percentage values you calculate. When you get the marks, your subject marks, you calculate the percentage value so that you get exactly how much you scored in the final examination. Or you, when somebody asks you how many marks you get in all these subjects, in that condition you can tell the range of marks you got, the lower range and the higher range. Okay, but the value which you want to tell as a single value will be the central value. Neither you tell a higher value, neither you nor you tell lower value. You tell the central value, which is called as mean, mode, or median, that we have learned. So these central values provide information on the spread. These ranges which provide information on the spread of the data around the center. And in this session, we will look at two measures of the dispersion called the variance and the standard deviation. Okay, so two sets of data may have same mean, but the observation in one set may be high congregative, whereas the other set observations may widely dispersed and around the mean. Okay. Here I will not give example because in the first year, if you have the books, you can go and check that the data, different kinds of data are there, but the mean will come same. Okay, but sometimes the many of values are near the mean, very few are dispersed. Okay, while in some data you get the values which are highly dispersed. Okay, म्हणजे अगदी लहान व्हॅल्यूज पासून मोठ्या व्हॅल्यूज पर्यंत डेटा असतात. म्हणजे जर तुम्ही लहान व्हॅल्यू म्हणून रिप्रेझेंट करायला गेलात तर ती व्हॅल्यू तुमचा डेटा रिप्रेझेंट करत नाही, हायर व्हॅल्यू पण करत नाही. मग त्याच्यावेळी तुम्हाला ॲव्हरेज व्हॅल्यू काढून सेंट्रल टेंडन्सी म्हणजे मीन काढावा लागतो. त्याचबरोबर काही वेळा अशा व्हॅल्यूज असतात की ज्या खूपशा सेंटरमध्ये असतात, तर काही व्हॅल्यूज ह्या लोअर व्हॅल्यूज किंवा हायर व्हॅल्यूज असतात. तर अशा कंडिशनमध्ये पण जो मीन येतो तो काय दाखवत असतो, सेंट्रल व्हॅल्यू दाखवत असतो. तर त्याच्यामध्ये असणार जे डेव्हिएशन आहे, म्हणजे जे डिस्पर्शन आहे, ज्या बाजूला गेलेल्या व्हॅल्यूज आहेत त्यांची व्हॅल्यू आपण कमी करू शकत नाही, आणि त्यासाठी आपल्याला स्टँडर्ड डेव्हिएशन मोजणं गरजेचं असतं. Hence, in order to get the true picture of the data, a measure of the central tendency has to be supplemented by suitable measure of dispersion. How much dispersion is there? How much range is there? How much percentile is there? That you have to calculate. Okay, then only you will get the clear-cut idea about the central value. Okay, so for example, you can take in some subject if you have got 35%, in some subject you have got 80%. Okay, if you'll tell you got 35%, that will also not represent your exact contribution in the studies. And neither if you'll tell 85%, if you'll tell 85%, that will also not represent your contribution in the studies. So in that condition, you add all the values and divide by the total number of variables. In that condition, you will get the central tendency or central value. Okay, but the values are dispersed. Somewhere they are 35, somewhere where they are 80. So how much they have dispersed, that you have to find out with the help of standard deviation. Some important measures of dispersion are range, mean deviation and the standard deviation. रेंज तुम्ही बघितलं असेल बरेचदा देत आहे की एखादी गोष्ट तुम्हाला मार्केटमध्ये गेलात की तुम्हाला तुम्ही म्हणता की फॉर एक्झाम्पल विल टेक द एक्झाम्पल ऑफ राईस. ओके, इफ विल गो इन द मार्केट यू विल गेट राईस which is 30 rupees kg and 120 rupees kg. Okay, so somebody will ask you how much what is the price of rice. In that condition you can tell it ranges between the 30 rupees to 120 rupees. On an average rice you get in 60 to 70 rupees per kg. Okay, so like that you can describe about the range. So if you want the central value, then you have to tell about the value which is more represented by more number of rice. Okay, so that is the central value and the dispersion around it. Okay, so variance and the standard deviation. The concept of standard deviation was given by Carl Pearson in 1893, and it is most widely used measures of dispersion. It is also known as the root mean square deviation because it is the square root of mean of square deviation from the arithmetic mean. Okay, so variance is the square root of deviation. So standard deviation is the positive square. Standard deviation is the positive square root of the variance. ओके, म्हणजे फॉर एक्झाम्पल जर तुम्ही काय बघितलं, standard deviation is the positive square root of the variance. The variance of the population is calculated as the average of square of deviations of observations from the arithmetic mean. While dealing with the variance of sample, the sum of squares of deviations of observations from the arithmetic mean is usually divided by one less than the total number of observations. So variance and standard deviation of the population are denoted by sigma square and sigma, that of sample deviation denoted by S2 and S square and S. Okay, variance and standard deviation of the population are denoted by standard deviation. We know it is denoted by sigma. So the variance is square of sigma. If you find out in the conditions of uh, if you take variance into standard deviation, variance is equal to square root of sigma. Sorry. Okay, so the formula for the standard deviation, here you can find out that for ungrouped data, the sigma square is equal to 1 divided by n summation in bracket x minus mu square, or 1 divided by n bracket summation x square minus summation x in bracket square divided by n. So for group data, sigma square is equal to 1n summation f is the frequency, uh, in bracket x minus mu square, mu is the mean. Okay, or 1 divided by n summation in bracket summation fx square in bracket minus summation fx square divided by n. So all these formulas are given for the formula for sample variance ungrouped data. S square is equal to 1 divided by n minus 1 summation x minus x bar square. Okay, so this formula is given. You can go through the formula. Okay, when you solve the problem, you'll understand how exactly you are going to use this particular formula. Formula for standard deviation. Standard deviation, now here it is correct. I was little bit confused earlier. Standard deviation is the square root of variance. Okay, standard deviation is, I was telling you variance is square root of standard deviation, but it is standard deviation is equal to square root of variance. Okay, so sometimes you get confused by converting this square root into square. Okay, so standard deviation is equal to square root of variance, or variance is equal to square of standard deviation. Okay, coefficient of standard deviation is the ratio of standard deviation to mean. Okay, for example, sigma divided by mu, or s divided by x bar. Okay, so what are the merits of variance? It is based on all the observations. It is based on all the observation, and it is least affected by fluctuations of the sample. It considers all the observation because you are taking considering all the observations, not only the central value. It can be used for further statistical computation. Okay, variance you can use for next level computations. Demerits, it is difficult to compute and it gives more weightage to extreme values. Okay, so let's study this example and you'll understand how you can calculate the value of variance. Okay, so calculate the standard deviation of the data on weight of prawn in grams. Calculate the standard deviation of the data on weight of prawns in grams. So it is the values are 32, 42, 52, 44, 36 and 58. So in this condition, x bar, mean x bar is equal to summation x divided by n. Summation x divided by n is equal to 32 plus 42 plus 52, all values if you'll add, okay, divided by 6. So it is 264 divided by 6. So mean, that is the x bar is equal to 44. Okay, so standard deviation is equal to square root of summation x minus x bar square divided by n minus 1. So x bar, how you can calculate x minus x bar? Okay, so x value is 32 and x bar value is 44. So 32 minus 44, it will come minus 12. 42 minus 44 minus 2. 52 minus 44 8. 44 minus 44 0. 36 minus 44 minus 8, and 58 minus 14, that is the 14. So square of this will be x minus x bar square, which is equal to, it is given in the last column. So summation x minus x bar square is equal to, if you add this and you will do the square, it will come to 472. Okay, summation of x minus x bar square. So 144 plus 4 plus 64 plus 64 plus 196, it will come to 472. Okay. So here you can get an idea about how to calculate the standard deviation, and then from that standard deviation you can easily calculate the standard variance of that data. Okay. So if you want to calculate the standard deviation, it will be the square root of 472 divided by 5, because the total number of variables will be are 6. Okay, total numbers 6. 5 minus 6 minus 1 is equal to 5. So square root of 472 divided by 5. So the square root of 472 divided by 5 will come to around 94 point, it will come around 9.7. Okay, you can calculate later on. So uh, s- basically you learn how much that is the deviation from the mean value. Okay, so how much it deviates plus minus in the around the mean, that is the 9.7. So next is the standard error. And standard error, it is the difference between the value and static of the particular sample x, or SD, standard deviation, and the corresponding population parameters, that is the mu, that means the mean, and the sigma, that is the standard deviation. It is thus a measure of chance variation and is also called sampling errors. Okay, sometimes you are taking these readings of what you can say, uh, our in a chemistry, you take this readings for some chemicals. Okay, and in that burette reading you have to take 3 to 4 readings, because sometimes you get the sampling error. Okay, these errors are additional errors. While adding, you can add some 1 point ml 1 point or 1 ml extra uh, in the sample, and which gives some or other kind of error. Okay, so in this titration method, while you are taking the CBR, okay, you take the average reading of three or whatever four. First, you take the pilot reading, and then you take the three readings. And when you want to take the final reading, you take the average out of all these 3 or 4 readings. So why? Because to avoid the sampling error. So when you are doing a lot of sampling, for example, you're studying the biodiversity, you're studying the population of any particular organisms, birds, insects. In that condition, you get sometimes some or other sampling errors. To avoid these sampling errors, and it may deviate your data. Okay, so to avoid these sampling errors, you have to find out how much error is there, sampling error is there uh, in your calculations. Okay, so it is very important, because again it is one of or other kind of standard deviation. Standard error is statistical term that measures the accuracy with which a sample distribution represents a population by using standard deviation. In statistics, a sample mean deviates. In statistics, a sample mean deviates from the actual mean of population. This deviation is the standard error of the mean. Okay, so standard error plays a very crucial role in the large sample theory. It also may form the basis for the testing of hypothesis. The statistical inference involved in the construction of the confidence interval is mainly based on standard error. It is inversely proportional to the sample size, meaning that the smaller samples tend to produce greater standard errors. Okay, so in the simple words, some values goes plus minus in the data, and these small values may change your result. Okay, so in all these kind of calculations, you have to use the standard error. So standard error, SE minus SE of x bar. X bar is a mean. Okay, arithmetic mean. When SE of x bar, standard error of the mean is, that is the standard deviation, or S. SD is the standard deviation, or S is the standard deviation of sample. N is the sample size. If the populations have same standard deviation, SE of difference between the mean is equal to, whereas x1 and x2 population mean, and n1 and n2 are the size of samples. If the two random samples where x1 and sigma 1 and n1, x1 sigma 1 and n1, and x2 sigma 2 and n2 are drawn from the population, SE is equal to uh, sigma 1 square divided by n1 plus sigma 2 square divided by n2, square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2, where sigma is the standard deviation of the population, n is the size of the sample. So this is the formula of standard error. So which are the factors which controls the standard error? The sample size, SE decreases with increase in the size of the sample. Standard deviation, the value of standard error vary directly with the size of standard deviation. The nature of statistic, for example, mean, variance, etc., can affect the standard error. The mathematical form of sampling distribution also affects the standard error. Okay. Then what are the uses of standard error? The standard error of the mean is used to measure the extent of sampling error in the mean. It helps to determine where the population is drawn from the known population or not. And it helps to calculate the size of the sample. Okay, now we'll take this example so that you can understand. The example given, systolic blood pressure of 400 males were recorded. Systolic blood pressure of 400 males were recorded, and the unbiased standard deviation are 10 mm. Calculate the SE of the mean. So here standard deviation is given 10. Number n is equal to 400 because we have taken the sample size of 400 mils. Okay, so standard error of x bar is equal to SD divided by square root of n is equal to 10 divided by square root of 400, that is the 10 divided by 14, that is 0.5. So standard error will be 0.5. So with this we have finished about the standard deviation, variance and standard error. Okay, thank you.